Welcome to Web Workers 101. In this video, we will see what a web worker is and how it can be useful. I'm Seth Poily and I'll be your instructor for this session. We will start by explaining a common user experience issue on the web. Then, we will see what a web worker is and how it can help with the problem. Finally, we will implement a web worker to improve on the user experience. Let's talk about the browser. For a single tab, the JavaScript runs in a unique thread, the main thread. This thread is not only responsible for running the JavaScript, but also updating the layout, which includes updating the DOM and performing paint operations. If the JavaScript takes too much time to execute, it can cause some problem with the interface. We want our UI to be responsive and never freeze. Our screens generally have a refresh rate of 60 frames per second. That leaves us with 16 milliseconds per frame. On frames where we need to update the interface, DOM and CSS updates will take around 8 milliseconds. We're left with 8 milliseconds to run our JavaScript, which is not much, especially on mobile. As mentioned, the main thread is responsible for updating the UI. That's why it is generally called the UI thread, and that's how we'll name it from now on. Let's have a look at an app that freezes when executing too much JavaScript. Here is our demo app. The important parts are the animation that indicates that the UI is doing fine, and the controls, the drop down and the button. When I click on the button, it starts, logs the results, and the process is done. All the app does is calculating the value of the Fibonacci series for a given number. Note that this function is recursive, meaning that it will call itself until it runs to completion. The bigger the number we give it, the longer the process will take. This is a good candidate for blocking the UI. Let's see what happens when we pass 43 this time. The calculation starts and the UI is frozen. The animation stopped and I cannot use the drop down. We wait a few more seconds and we will get the result back. Now that the processing is done, the UI is responding again. We can see the animation and we can use the drop down. A web worker is just another thread in the browser. We can execute some JavaScript there without slowing down the UI thread. When we have a web worker in place, we can have the following setup. A UI thread that mainly handles the DOM and paint operations. It will also send data to the worker thread. When it receives a request, the worker will be responsible for performing the laborious JavaScript operations, and then send back the result to the UI thread. The UI thread receives the data and performs simple operations to update the DOM. By offloading the heavy JavaScript tasks to the worker, we keep the UI thread free for updating the interface as needed. We then have a responsive UI. Let's have a look at our app and fix it by implementing a web worker. So right now, our app freezes when we pass it a big number. Let's add a web worker to our code to fix that behavior. To create a web worker, we simply have to call its constructor and pass it a string. The string represents the file we want the worker to execute. Here, worker.js. Let me create that file, worker.js. And I'll paste a console log statement there to check that everything is working fine. Now we can see the log from the worker. And in the source panel, in the thread section, we can see something really interesting. We have our main thread and also our worker.js thread. Our web worker is ready. Now let's fix our app. instead of calculating the Fibonacci number on the main thread, we will send the request to the worker, and for that, we use worker.postMessage and pass it the position variable. It will send a message event to the worker. On the worker thread, we need to listen for that event. We will assign a function to the onMessage property. That function takes an event as argument, the message event. We want to calculate the Fibonacci value and send it back to the UI thread by using postMessage, as we did on the other side. For the sake of this video, I will simply copy the code for calculating Fibonacci and paste it there in our worker code. Now that we have access to that function, let's complete our code. And here we are. We have the Fibonacci value and we are posting it back to the main thread. On the main thread, we now have to listen to the event that the worker is sending. For that, we will implement worker.onMessage and pass it a function. Inside of that function, we will log event.data, which contains the final value. We also add a debugger statement so that we can follow the call stack in the browser. If I click on calculate, we can see that we started from the UI thread. Then we went to the workers thread, and then finally back to the UI thread. And if we check the value for 10, it's 89 as expected. Now let's skip the breakpoint and see how it goes for 43. We can see that the process has started and the animation is still running, and I can still use the drop down. And we wait a few more seconds and we will get our result back. And the app was working all the way. The UI was always responsive. In this demo, we've discovered the basic API of the web worker. On the UI thread, we have created a worker and got a reference to it. We posted a message to the worker and added an event listener to receive the worker's response. On the worker thread, we've listened to messages from the UI thread and sent back a message to the UI thread. That's all for Web Workers 101. In the next video, we will have a closer look at web workers and how to do more complex things with them. If you dislike this video, you know where that button is. If you enjoyed it, please like, subscribe, comment and share. I'll see you in the next video. Until then, happy coding!